Hi students, the next part of your organic chem, we are going to look at fuels. Okay, so fuels, when you see the word fuels, what do you understand? Okay, we burn fuels for energy. Okay, so common examples of fuel are your petroleum, which is the same as your fossil fuels, and hydrogen. Okay, what happens is when I burn hydrogen, you should know oxygen is needed for burning to give you water. Okay, write your balance equation. This equation is highly exothermic. So energy is given out, hydrogen is used as a fuel. Okay, and then the other example of fuel is your petroleum, which is also known as fossil fuel. Okay, so petroleum, fossil fuel, or the crude oil, these occur when the dinosaurs die millions of years ago. So when your dinosaurs die, you know, the remains, the carbon and hydrogen from the dinosaur's body, right, is being decomposed, right, and then it enters the soil or the environment. Okay, and then millions of years later, you know, with the heat compression from the earth and all that, right, humans nowadays, we dig out the fossil fuel, or we dig out what we call the petroleum or crude oil, which is a dark black liquid, right, and then we burn it for energy. So we burn it, for example, for your cars to power, for your cars to move. We burn it to produce electricity, for all your appliances. Okay, and we burn it for example, factories will burn it for energy. Okay, so common components of fuel. So when we talk about fuels, we will say there is the natural gas. Okay, so methane, CH4, this one we also can burn it for energy. Okay, coal, this is the black stuff that you dig out from the soil, as well as from that you use for barbecue. So coal is actually like charcoal. The element itself is carbon. And then petroleum and crude oil, this one I tell you about the dinosaurs just now. Okay, so this methane, natural gas, coal, which is the barbecue charcoal, as well as the petroleum and crude oil are the three main components of fuel. So all of these we will burn it for energy. Okay, petroleum. So petroleum and crude oil is what we are going to look at in detail. Okay, petroleum and crude oil is the same substance. We also call it fossil fuel, right? This is a mixture of hydrocarbons. So this is your black foul-smelling liquid. Okay, don't confuse the word petrol with petroleum. So petroleum is the crude substance. Okay, the components of hydrocarbons in petroleum have different boiling points, so they can be separated by fractional distillation. Okay, so when you dig out the fossil fuel, when you dig out the petroleum, there's actually different parts. Okay, so this thick black liquid, or this thick black fluid, is actually made out of different components. We also say different fraction. Okay, and then each fraction that comes out when you perform fractional distillation is still a mixture. It's a mixture of hydrocarbon with a particular range of boiling point. Okay, each fraction has similar numbers, and these similar numbers of carbon and this one will result in almost the same or similar physical properties. Okay, the size and mass of hydrocarbon increases due to an increase in the number of carbon atoms. And then this increase in number of carbon atoms, this one will result in a trend in the physical properties, which we will see and explain it moving forward. Okay, so this picture we have to memorize. Okay, so this picture shows you your fractional distillation. So when you dig out the petroleum, right, you dig out the petroleum, you put it over a boiler or a heater, right, the thick liquid, turn it into gas, the gas enters your fractionating column, and this fractionating column, you have to remember this. Okay, so I remember the different fractions that come out as really great noble kings. Don't forget lady's birthday. So really, the first part is my refinery gas. So over here, refinery gas, really. Okay, so refinery gas, what is it used for? It is used for cooking. Okay, so now a lot of us, we use electric stove, but in the past, right, to cook, we actually use gasoline, which is also known as, we actually use the refinery gas. Okay, so refinery gas is still a mixture by itself. It is made from 1 to 4 carbon. Okay, so what is the first fraction? What is it used for? We have to know. Second fraction is the grade. Grade is your gasoline. So gasoline is also known as your petrol. So the petrol that cars use, you have to know what is it for. It's the second fraction. Generally speaking, is about 5 to 10 carbon. So this first one is gas, then the petrol onwards becomes liquid. Okay, really great, noble. So noble is my naphtha. So naphtha, what is it actually? This is used as feedstock in petrochemical industry. So feedstock meaning to say it is mostly the starting materials of making paints, for example, making different chemicals, and it is 7 to 14 carbon. It is a mixture. Okay, then we have Kings. So Kings is my kerosene. Okay, kerosene, there's another name also known as paraffin. So kerosene, this one is used in kerosene lamps as well as oil. It is the fuel that aeroplanes burn for it to move. Okay, Kingstone, we have the diesel. So diesel, the next fraction, is also known as fuel oil. Okay, so diesel and fuel oil, this one is used in diesel engines. So diesel engines is like your lorries, the vans. When they go and pump, they don't pump petrol, they pump diesel. Okay, and then fuel oil in ships. So the big vessels that you see out at sea, right? What powers them? It's not the petrol, it's not the kerosene, it's what we call the fuel oil. So don't forget, this one is your diesel plus your fuel oil. Ladies is the lubricating oil. And then birthday is your bitumen. So the last two fraction we have over here is the lubricating oil. This one is used as a lubricant to make waxes, polishes, to lubricate machinery parts so that they can run smoothly. And then we have bitumen, the last one. This is used to make roads. So you see your bitumen, this is more than 50 carbon. Okay, so generally speaking, these are all liquid. And as you go to bitumen, it will be almost solid. It will be like thick, solid, light, so that you can make roads. Okay, so this range or this series or this sequence where the petroleum, the crude oil, is separated into the different fractions and what is it used for, you have to know. Okay, so we are going to look at some of these physical properties. Okay, physical properties, how do they change as the number of carbon increases? So for example, your first fraction, you have the first carbon, second carbon. So again, these are all hydrocarbons, third carbon, and then last one, your fourth carbon. This is your first fraction, okay, and all these are refinery gases. Okay, so what happens is this is your simple molecular structure. Remember covalent bonding, your carbon and hydrogen, they exist as individual molecules, but it cannot be one molecule make up the methane, CH4, that you see. So there is actually a lot of CH4. Many molecules of CH4, then we say this is your methane. Yeah, this is one molecule, another molecule, another molecule, another molecule. Simple molecular structure. Okay, when you boil methane, the bonds don't break. If it breaks, your CH4 is no longer CH4. So we are not breaking the covalent bonds. What are we breaking? When we boil it, We are just changing in state. We are breaking these green lines that I just draw. This is your IMFOA. So weak intermolecular force of attraction. Right? So simple molecular forces, simple molecular structure, they have weak IMFOA between molecules. So we have to write it exactly. It's weak intermolecular force between the molecules. So what happens when the size and mass increases? So from your carbon 1 become your carbon 2 example. Okay, and then for example, if we have another carbon 2. Right? Again, this is one molecule, this is the other molecule, this is the other molecule. The difference between A and B is that the carbon increase, the size and mass increase. So the carbon increase, carbon atoms the size and mass increase. So when your size and mass increase, right, what will be changed? This will affect the IMFOA. So it's like a magnet. If I have a small magnet to a small magnet, the attraction, I can break it very easily. But if I have two very big magnets and I try to separate them, the magnetic strength is so strong that it is harder to separate them. So when your size and mass increase, what happens to the IMFOA? Right? The IMFOA, the strength of IMFOA increases. The strength of the intermolecular force increases. Okay, so you need a larger amount of energy is needed to overcome the stronger IMFOA, so your boiling point increases. Right, so as I was saying, when your molecule size and mass increase because the number of carbon increases, the IMFOA becomes stronger. It's like magnet, it becomes stronger. So to overcome this IMFOA, I need more energy or large amount of energy. Right? So the boiling point will increase. Okay, so the intermolecular forces between the molecule increases because the size of the molecule increases due to increased carbon atom. More energy is needed to overcome the attraction force, boiling point increases. This is your explanation. Okay, this is where your boiling point increases when the carbon increases. Next one, viscosity. Viscosity means how thick is it. Viscosity will increase as carbon increase. Means the longer the chain, the more thick it is, the harder it is to flow. Okay, same idea. Okay, the intermolecular force increases because the size and mass increase. So the forces are more difficult to overcome. Right? They have stronger forces of attraction, and the larger hydrocarbons become thick or waxier. So they do not flow easily. Right? I need more energy to overcome the forces of attraction. So it's harder to overcome now. So it is thicker and waxier. It's harder to flow. It is more viscous. Okay, volatility means it turns into gas easily. So when the size and mass increase, your volatility will decrease. Means it is harder and harder to turn into gas. Okay, same idea, intermolecular force increase due to the size and mass increase. Okay, larger amount of energy needed to overcome this strong attraction, so that it's harder for the liquid to turn into gas. So it is less volatile, it is harder to turn into gas. Okay, so in fact, these 3 points all boils back down to this covalent bonding explanation that you have learned before in chem bonding. Okay, so let's look at this last idea, right? When the carbon increase, it becomes less flammable. Less flammable, it is harder to burn. Okay, so when it is flammable, right, we use this idea called the percentage by mass of carbon in the molecule. Okay, so if I have a combustion reaction, for example, my methane burning to give me carbon dioxide and water. Okay, burning means you need oxygen, so oxygen has to be one of your product. Okay, so find the percentage by mass of carbon in methane, right? So it's 12 mass of carbon divided by the mass of the whole molecule, you get 75%. And ethane, ETH, remember this is 2 carbon, so it's C2H6, and they are all single bonds. Okay, plus oxygen, again this is your combustion reaction. This one will give you CO2 plus H2O with energy given out. Okay, balance out your equation, you will get by right. Okay, balance out your carbon, put a 2 in front, balance out your hydrogen, put a 3 in front. Okay, and then total I have 7 oxygen atoms on the right. So this one should be 7/2. 7/2 of O2, then you have 7 oxygen atoms. But you cannot leave it at 7/2, so bring your 2 to everybody. Right, so your final answer will be, bring the 2 to everybody, this one will be 2, this one will be 7. Okay, don't leave it as a fraction. Then 2 times 2, this is going to be 4, and 2 times 3, this is going to be 6. Okay, so if you look at these two formulas here, or these two equations, I have my methane equation and my ethane equation. Right, 1 methane, 1 CH4 need 2 oxygen. Let me write it down. 1 CH4 need 2 oxygen to burn. And then 1 C2H6 needs how many oxygen? 7 out of 2 oxygen. So in fact it needs 3.5 oxygen. Because in my balance equation is 2:7 ratio, so if I have 1 ethane, I should have 3.5 oxygen. Okay, so you can see that this, which is easier to burn, 2 oxygen or the one that you need 3.5 oxygen? Of course, is methane. Methane is easier to burn, okay, but why is it easier to burn, right? So same thing, let's count the percentage by mass of carbon. So this one, there's 2 carbon, so 2 times 12. Okay, divide by the whole molecule's mass, so 2 times 12 plus 6, because there's 6 hydrogen. 80% times 100, 80%. That's my percentage, yeah. Okay, so looking at these two values, right? I have a 75% over here. Percentage by mass of carbon is 75%, and the percentage by mass of carbon in ethane is 80%. So what happens? As the number of carbon increases, the percentage by mass of carbon increase from 75 become 80. Okay, why does it increase? This is due to the increase in mass and increase in carbon atoms. So the hydrocarbons become less flammable. You need more oxygen to convert the carbon to CO2. So it's less flammable, more oxygen is needed to burn. Okay, so these are your explanation for the physical properties of your hydrocarbons, the fossil fuels or the petroleum that you dig out from the soil. And these petroleum and fossil fuels are mostly your hydrocarbon with single bond, okay, mostly your alkanes.